On this problem, we want to find the intervals where f is increasing and decreasing. So we need to find critical values because functions change from increasing to decreasing or vice versa at their critical values. So we need to find the derivative. So we get negative 60x to the fourth plus, let's see, 135 times 4. I'm going to pull out the calculator for that one. 135. Okay, times 4 is 540, so plus 540 x cubed minus 1200 x squared. Okay, so we need to set that equal to 0. I'm recording a video, sweetheart. To solve for the critical values. Okay, so we need to solve this equation. I'm wondering, first off, is 540 divisible by 6? Let's see. 9, yeah, everything should be divisible by, oh, I meant to put by 60. Is 540 divisible by 60? Yes, nice. Okay, so let's take a negative 60x squared out of everything to make this easier to solve, leaving us with positive x squared minus, I think that's a 9x plus, let's see, 1200. 1200 divided by 60 is 20. Yeah, equals 0. Okay. And let's see, does that factor? So I guess if we did minus 5 minus 4, it will factor. X minus 5 and x minus 4 seems to work. Okay, so then setting each of these three factors, that one, this one, and this one, equal to 0 gives negative 60x squared equals 0. X minus 5 equals 0 is going to be x equals 5, and x minus 4 equals 0 will give us x equals 4. This one is going to give us x equals 0. So we have three critical values, 0, 5, and 4. So those are the x values at which the function may or may not change from increasing to decreasing or vice versa. So we need to put those numbers on a number line and test the function to see if it's increasing or decreasing on each side of each critical value. So that broke up the x-axis into negative infinity to 0, 0 to 4, 4 to 5. And I understand that, you know, when you're working your homework, you can just look at the graph and actually figure this out, but you do want to make sure you can do it algebraically. Without a graph to show that you understand what's going on. So for test values, I'm going to choose negative 1, 2, 4.5, and 6. And here we're plugging into the derivative. F prime was, I'm going to copy it again. You know what, let's plug into the factored version. It's going to be much easier. So this is the factored version of f prime right here. Okay, so that's what I'm plugging into down here. All right, so for f prime of negative 1, so you can follow with me here, it's negative 60, so it's negative, times negative 1 squared is a positive factor, times negative 1 minus 5 is going to be negative, and negative 1 minus 4 is also negative. So it's a negative number times a positive times a negative times a negative is a negative value. So f prime of negative 1 is some negative number. I don't know what. Now let's try, you know what, let's just plug in 1. F prime of 1, let's see, we still have the negative 60 out, so that's negative. 1 squared is positive. 1 minus 5 is negative 4, and 1 minus 4 is negative 3. So same thing, f prime is still negative there. 4.5, okay, we got negative 60 still is negative. 4.5 squared is a positive number, times 4.5 minus 5 is just barely negative, and 4.5 minus 4 is positive. So it looks like the derivative is positive there. And let's see, plugging in 6. So negative times a positive times 6 minus 5 and 6 minus 4 are both positive. So that derivative there is negative. So that tells us f is decreasing on that interval. Just a moment. Decreasing on that interval, increasing on that interval, and increasing on that interval. So, technically, let's see, the answer would be that f is, just a moment, Jim, decreasing on the intervals from negative infinity to, right here, to 0, and from 0 to 4, and from 5 to infinity, and it's only increasing on the interval from 4 to 5. That's where we got a positive number. But let's go over to my math lab here, if I can find it. Where's this problem? Here it is. Okay, so it's increasing on, goodness, what did I say? Negative infinity to 0, 0 to 4, negative infinity to 0, 0 to 4, and I think it was 5 to infinity. Let's double check that. Yeah, and then increasing from 4 to 5. Okay. Oh, I did that backwards. Let's move that over to decreasing. Just a moment, sweetheart. Yeah. Okay, and it's increasing from 4 to 5. Now, I think it's going to tell me that this is wrong. Oh, no, apparently correct. Okay, I saw one student, hold on a minute, where it said it was wrong because they had included the 0 there. At least that's what it looks like. So I'm a little surprised that it gave me that. If it does tell you that this is wrong, try just putting, let me show you right here, from negative infinity straight all the way to 4 instead of breaking it up at 0. Technically, the function is not increasing or decreasing at 0 because the tangent line is horizontal. Okay, so anyways, hopefully that helps on that one.